Hello everyone, welcome back to this video. We are going to explain in this video chapter 2 in the chemistry course, which is bonding. In this chapter, we are going to learn what types of bonds do these atoms or do these elements actually, when they combine with each other, they form bonds. What type of bonds they have? This is really important part, and this is really important chapter, and it is considered as well as a basic of chemistry. After knowing the atomic structure, which is chapter 1, and after we know everything related to the atom, electron configuration, and the periodic table, trends, and the properties, we are going to go now to the bonding. If we have two elements, when they are going to bind to each other, of course the elements, they bind to each other because they make chemical reaction. When they combine to each other to form a compound, they make a chemical reaction. If you look to this periodic table, we have all these elements in the periodic table. As we said in the previous video, periodic table is divided into two types. These are metals, group number 1 and group number 2, transition metals, and some of group number 3 are metals except the boron, and nonmetals at the left side of the periodic table. Nonmetals, which are group number 5, 6, 7, and 8, of course they are noble gases. And you should mind that we have metalloids in between group number 3 and 4, like boron, silicon, germanium, and so on. Now, the type of bonds these elements actually make depend on the type of the element. What do you mean, teacher? Please look to this explanation. If I am going to explain the type of bond, I will actually say that we have three basic type of bonds. These elements actually make when they combine to each other. Number 1, ionic bond, and I am sure that you have already heard about the ionic bond. Number 2, metallic bond. The last one is covalent bond. Yes. When we say that this is ionic bond, it's so easy. Now, when two metals when metal with non-metal combine with each other, I mean elements in group number 1, 2, 3 with elements with group 5, 6, and 7, when they combine to each other, they make ionic bond. So again, this is metal with non-metal. This is ionic bond. The most important or the most, let's say, famous example, the sodium is in group number 1, chlorine is in group number 7. This is ionic compound. We can say that I have magnesium and Br2, magnesium bromide, and so on. These are ionic bond, which is metal with non-metal. We have a lot of information related to the ionic bond. We are going to explain it a few minutes later. We are going to learn how to name the ionic compounds. What is meant by a compound? What is the difference between compound and molecule? And many more to come. Number 2, the metallic bond. The metallic bond is a bond in a one metal. Is a bond that attract the positive and negative ion inside the one metal. For example, if you have iron, if you have copper, all these metals, if you have sodium, all these metals, the one metal is attracted, all the particles inside this metal are attracted to each other by metallic bond. Of course, the metallic bond is a bond for metals, and the non-metals, they don't have the metallic bond. So whenever you see iron, copper, sodium, any metal, it's easy to utilize and to detect that these are metallic bond. Finally, I have covalent bond. Actually, the covalent bond is non-metals together. I mean non-metal with non-metal. Non-metals together, they form non-metals together, they form covalent bond. Covalent bond mean sharing of electrons. these electrons are shared, they are not lost or gained anymore, which are nonmetals together, they share electrons. So this is sharing of electrons. Okay, and of course here the ionic bond is losing and gaining of electrons. Okay, losing or gaining of electrons, but the covalent bond sharing of electrons. We are going now to understand what do we mean by losing, gaining, and sharing of electrons. Non-metals together, for example, the most important covalent bond is NH3. We have, this is ammonia, we have H2O, the water, we have CH4, the methane, and so on. So if you can see that all of these are nonmetals together. When you bind them to each other, they make covalent bond. For example, if you have the CO2, this is really important, CO2, and you have the NO2, all of these are nonmetals together, like group number 4, 5, 6, 7, yes, when they bind to each other, they make covalent bond. Of course, the group number 8, the noble gases, are not concerned in the bonding procedure because they are already octet and they don't need to make chemical reaction because they are octet. That's why it is called noble gases. Let's start to explain briefly about the ionic bond. In this part of the video, we are going to briefly explain part of the ionic bond, part of the covalent bond. In the next video, we are going to go through the chapter. We are going to open the slides and learn how to draw Lewis dot structure. Please concentrate. Look here to this periodic table. If we are back to our periodic table, I would say that each one of these groups, as we said, each one of these groups, I mean the elements in each one of these groups, they lose or gain electrons in order to be octet. It means in order to have 8 electrons in the last orbital. It means they are stable, they are octet and stable, they don't need to go through any chemical reactions. So actually, these elements, when they combine to each other, first they do compounds, they make compounds, yes, and they make chemical reactions which are important in our life. Consider that these elements, they don't undergo chemical reaction. Consider all these elements are already occupied and octet. Yes, so none of these elements are going to make any chemical reaction. So that's why each of these elements actually follow or undergo a specific type of reaction based on the type of this element. When they combine to each other, they make compounds or molecules, and they are now octet. They have 8 electrons in the last orbital. Now, group number 1, if you look here, please, group number 1, it means they have 1 electron in the last orbital. Now, I want to make it 8 electrons in the last orbital. If you take, for example, the sodium here, the sodium has 11, so you would say 1s2, 2s2, 2p6, 3s1, right? Now, if you look to the last orbital is 3, the last subshell is 3, and look to the sodium. Now, sodium must have 8 electrons in the last orbital. You ask yourself, which one is easier for the sodium? To lose one electron from the last shell, and look, how many electrons do I have now in the last shell? Now the last shell is 2, the highest n, 2, 6 plus 2, 8. So if I remove this 1 electron, I will end with 8 electrons. So for group number 1, which is easier, to lose 1 electron or to have or to gain 7? Yes, it's easier for group number 1 to lose 1 electron. So actually, group number 1 all, they lose 1 electron and they have positive 1 charge. For the group number 2, it's the same. Group number 2 is the same. Let's take, for example, magnesium with 12, 1s2, 2s2, 2p6, 3s2. For more explanation about the electron configuration, please, you can find the previous videos that we have explained the electron configuration through those videos in a very good way. So you can go back to these videos, please, and just revise the electron configuration. Which one is easier for group number 2? To lose 2 electrons, and now it is end with the highest n equals 2. 6 plus 2 are 8, so it has 8 electrons in the last orbital. Or it is which one? To lose 2 electrons or to gain, to hold 6 electrons? Yes, excellent. It is easier to lose 2 electrons. So actually, group number 2, they lose 2 electrons, so they have a charge of positive 2. Now, please skip the transition elements because they have different consideration. As I told you before, we are going to have a separate video that explains the transition metals. How do they lose? How do they gain? How do they lose? Of course, electrons. They don't gain because they are metals. They lose electrons. And the distribution of the orbitals are different than what we explained earlier. Now, group number 3, they have 3 electrons in the last orbital. The same thing. Which one is easier, to lose 3 electrons or to hold 5? Yes, it is easier to lose 3 electrons. Excellent. So group number 3, actually, they have a positive 3 charge. Now, going to group number 4. Which one is easier for group number 4? To lose 4 electrons or to gain 4 electrons? What do you think? Yes, excellent. It is group number 4. They don't lose electrons. They don't gain electrons. They share electrons. So group number 4, they share electrons, but sometimes in the oxidation number, if you are going to have the oxidation number, they have positive 4 or minus 4. Let us leave it a little bit later when we take the redox reaction chapter. We are going to learn that group number 4 has an oxidation state, but in a different way. Group number 5, they have 5 electrons in the last orbital. And if you remember last time, we say that group number 5, they have 5 electrons in the last orbital, which means these are the valence electrons. And valence electrons represent the group number, which is responsible for the chemical reaction and the properties for these elements in the group. Which one is easier for group number 5? To gain 3 electrons or to lose 5? Yes, it's easier to gain 3 electrons. So starting from group number 5, elements start to gain, to take electrons. So they have negative 3 charge. Teacher, why negative? Because the person who always take, the person who always gain, the person who always love to take from people is a negative person, right? So we give negative sign. But the person who always give, who always donate, who always love to give things to people, he has positive charge, right? So that's it's important not to get conflict between the charges. Group number 6, which one is easier for group number 6? To have 2 electrons, like to gain 2 electrons, or to lose 6? Yes, easier to gain 2 electrons, so we end with minus 2. And the group number 7 as well, it is easier to gain 1 electron, it is minus 1. And for group number 8, they have no charge because they are already octet. After you know all of these charges, now it is easy actually to know how ionic bond form. Now, group number 1, group number 2, the metals, they combine with group number 5, 6, 7, the non-metals to make ionic bond. And I am going to give you 2 ways. The easier way that you can write any ionic compound between 2 elements, how to write this compound when they lose and gain electrons, and the other part is by drawing. You should know how to draw it correctly. I'm going to give you example of ionic compound that is formed between, for example, sodium and chlorine. Okay, let's have this is easy part, but just to understand how the ionic bond form. Okay. Let's see, I'm going to see, this is sodium and this is chlorine. This is how to write. Sometimes in your external questions or in your external exams, they have questions that they draw the outermost shell of each element and they represent the ionic bond, the gaining or losing of electrons. That's why it's important actually to know how to draw it. But you are not asked to draw it in the exam. You are asked to know the drawing for the ionic bond formation. Again, you are asked to know how to draw the ionic bond formation, but you are not asked to know how to draw it. And you are not asked to draw it in your exams, in your external exams. I am talking about the external exams, as they are all multiple choices. Now, the sodium is in group number 1. In this state, we only draw the valence electrons, which means the electron in the last orbital. So I have only 1 electron here. Chlorine are in group number 7. So I only draw the electrons in the last orbital, which are 7 electrons. But please, please, please focus, how do I draw the 7 electrons? Based on Lewis dot structure that we are going to explain a few minutes later. Lewis said when you are going to draw the valence electrons for this element, you first draw the first 4 electrons individually and then you pair. Again, what do you mean, teacher? I have 7 electrons. I draw it in this way. 1, 2, 3, 4, 5, 6, and 7. So I first draw the 4 and then I pair. Okay, teacher, see, if I see 1, 2, 3, 4, 5, 6, and 7, it is the same. Yes, by chance, it is the same. But look for nitrogen, for example. Nitrogen is in group number 5, right? See, teacher, you have to draw it this way, and this is called Lewis dot structure. Nitrogen is in group number 5. I'm going to draw it here in a correct way, and I'm going to write it here in incorrect way. Nitrogen is in group number 5, so I have to draw 5 electrons in the last orbital by Lewis dot structure. 1, 2, 3, 4, and then I write 5. So how many unpaired electrons do I have? 3 unpaired electrons. Correct. For the nitrogen in the other way that students actually they used to draw it, 1, 2, 3, 4, and 5. So how many unpaired electrons do I have here? Only 1. So this is 100% incorrect. Please, 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 please focus not to draw the valence electrons in this way that students actually sometimes they get mistake with. Please draw it in the proper way, which is Lewis dot structure. That number of valence electrons, you have to draw it the first 4 electrons individually and then you pair. After this, teacher, move please to this electron. Sodium doesn't need this electron, and chlorine needs only 1 electron to be octet. So this electron is transferred from the sodium to chlorine. In your external exams, you will find this arrow. This arrow actually represents the transformation of the electron, which means here I have ionic bond. So it is represented in your external exams or in the past papers as an arrow. Even in your books, you would find an arrow. It means this electron is transferred. And then I have the NaCl. The NaCl, the ionic bond, we don't draw the bond, like we don't say NaCl, okay? But if you are going to write it like this, you are just going to represent that this is ionic bond. Okay, this is easy one, this easy example. Let's move to a little bit more complex example that we have different elements. For example, I'm going to have magnesium with chlorine, okay? Magnesium with, let's say, bromine, okay? Magnesium is in group number 2, so it has 2 electrons in the last orbital. This is 1 electron and this is 2 electron. Okay, I will draw it here. Bromine is in group number 7. It has 7 electrons by Lewis dot structure. 1, 2, 3, 4, 5, 6, and 7. Now this electron actually is transferred from the magnesium into the boron. Now the boron now here is octet. It has 8 electrons in the last orbital and it's octet, but actually the magnesium here is not octet yet because it still have another electron. The magnesium atom has to lose it to be stable. Do you remember the first ionization energy and the second ionization energy for group number 2? We say the group number 2, if they lose only one electron, they are unstable at all. When they have 1 electron left, because they tend to lose 2 electrons to be stable. So this magnesium will go and call another bromine. Hey, please, another bromine atom. Yes, come please, I'm gonna bind with you. Okay, I am here, another bromine, and I'm going to draw 1, 2, 3, 4, 5, 6, 7, and I'm going to take this poor electron. It's not poor anymore. I'm going to add it to this collection. Now this bromine is octet again, and this magnesium is octet again. So I have Mg, only 1 atom of Mg, Br, how many bromine do I have? 2, so Br2. Easy, right? This is ionic bond, losing and gaining of electrons. Let's have the last example, and then I'm going to give you an easy way to know how to write this compound with no need to draw. Consider that you are in exam and you have no time, and you are asked to write the compound. I just want to remind you that this is called compound, okay, because in the covalent bond, we name it a molecule. The ionic bond, we name these elements, the new formation of the combination of the elements as a compound. Consider that you are in an exam and you are asked to draw the compound that is formed between, for example, aluminum and sulfur. Okay, or for example, aluminum and oxygen. Yes. I will draw it here. See, this is my aluminum atom, and this is my oxygen. I want to draw the compound that is formed between aluminum and oxygen. I have 2 ways. The first one is to draw atom by atom, losing and gaining of electrons, and it's gonna take more time. And the other way, which is easy, that I'm going to teach you. See, please, but you have to know the drawing, because in your external exams, the drawings actually come a lot. The aluminum is in group number 3, so I will draw only 3 electrons, 1, 2, 3. Oxygen is in group number 6, I will draw 1, 2, 3, 4, see, 5, and 6. Now, this aluminum actually tend to lose 3 electrons. Okay, the first electron will move to this oxygen, and the second electron will move to this oxygen. And now this oxygen is octet and stable because it has 8 electrons in the last orbital. Count 1, 2, 3, 4, 5, 6, 7, and 8. But for this aluminum, for this poor aluminum, it only has 1 electron left, which is unacceptable. So this aluminum will go and call another oxygen. Hey, please, another oxygen, can you come to help me? Okay, I will. The other oxygen will come with its 6 electrons, 1, 2, 3, 4, 5, 6. Okay, and then this aluminum will transfer this electron to the oxygen. It's here. Now, this aluminum is octet, but look what happened to the oxygen. Oxygen now has 1 electron left, unpaired electron, and it needs actually to gain more electron. So the oxygen here will go and call another aluminum. You see? Please, can I have another aluminum here? There is a problem. Okay, another aluminum will come directly to solve your problem, oxygen. This is my aluminum, this is my 3 electrons, and what is your problem, oxygen? My problem is that I have 1 unpaired electron. No problem, take 1 and put it, I will pair it with your unpaired electron, and now you are already octet. But what happened to this aluminum? Aluminum usually loses 3 electrons. It's not acceptable to keep aluminum with only 2 electrons, right? So the aluminum will go and call another oxygen. See? This is the other oxygen with its 6 electrons again. 1, 2, 3, 4, 5, and 6. Now, these aluminum will say, okay, oxygen, take mine. And you, the aluminium, the other electron here I will lose it here. Now, I am as an aluminum octet. I have 8 electrons in the last orbital. I lost 3 electrons as I'm supposed to do. And I am the oxygen now octet. You see, this is a transformation of ions, and this is how ionic bond forms between the aluminum and oxygen. If we are going to write the compound, now the compound is Al2O3 because I have 2 aluminum and 3 oxygens. Okay, teacher, this is really impressive. But do I need to draw this in each single question in my exam or even in my practice? Consider that I have no time. Can you please, teacher, give me an easier way to write the compound for any ionic, the compound, the formula of the compound for any combination of 2 metal and non-metal? Yes, it's so easy way. See, if you have, for example, 2 elements like metal and non-metal. For example, if you have the aluminum again and you have the oxygen, and I will write again my magnesium and my bromine. No need to draw what we was drawing before. You would say aluminum in which group? 3, so it has a charge of positive 3. Oxygen in what group? 6, so it has a charge of -2. Teacher, if you still have a problem with the charge of each group, you would not be able to solve this question in this easier way. I don't ask you actually to memorize each element in what group. No, it's easy. You can move to the periodic table. You see oxygen in group number 6. Yes, but after repetition and after you repeat this example many times, you would memorize that oxygen is in group number 6, right? So no need to go back to the periodic table in your exams to know that oxygen is in group number 6. After this, oxygen is in group number 6, so we put -2. Then you don't look to the charges, okay? You do cross multiplication for only the numbers without the sign. Without the sign, again, without the sign. No need for the positive, no need for the negative. I do cross multiplication. The 2 comes here, the 3 comes here. So I have Al2O3. If we go back to the previous example, see, it's Al2O3, the same. So this is how we actually wrote the ionic compound by drawing, and this is how we draw it by the easier way that you are going to use in your exams. Okay, now let's move to the other example. And now, the other example that we explained before by drawing is magnesium bromide. Magnesium is in group number 2, so it has a charge of +2. Bromine is in group number 7, so it has a charge of -1, -1. Then you don't take the sign, positive or negative, you only take the numbers and you do cross multiplication. The 2 comes here, the 1 comes here, and then I will end with MgBr2, magnesium bromide. And if we are back to the previous one, see, this is our magnesium bromide MgBr2. So now it's easy now. It's very easy to have to use this way in your exam, like a fast way or quick way. Let's have a last example. For example, let's consider that we have potassium. Okay, potassium is in potassium K, and then we have or aluminum. For example, let me give you an easier one. Aluminum with sulfur. Now you say aluminum is in group 3 and it has 3 electrons in the last orbital, so I will draw +3. Sulfur is in group 6, so it has 6 electrons in the last orbital, so it has a charge of -3. When you do cross multiplication, it is now -2. I'm sorry, -2 here. Yes, thank you for correcting this. I heard you. Al2 S3. right? Because you do cross multiplication, the S comes here, the 2 comes there. This is how to make the compounds. This is how the ionic bond forms actually. Still, we have properties of the ionic bond, like melting point, boiling point, and we have the most big and important part in the ionic bond, which is naming the ionic compounds. Now, actually, let's move a little bit to talk about covalent bond and how the bonds formed in the covalent bond. Briefly, like a small explanation. Now, in the covalent bond, let's move here. For example, I have the carbon and hydrogen, right? Which is the most famous, which is methane gas. Now, the carbon is in group number 4. So it has 1, 2, 3, and 4. When I look to these elements, I would find that these are non-metals together. So I am already prepared that there are going to be covalent bond, which is molecule, right? Now, and I have hydrogen, so I need 4 hydrogens actually, because each hydrogen has only 1 electron in the last orbital. And the hydrogen is octet. The hydrogen is octet at 2. So please, teacher, again, concentrate. Not all the elements, they are stable, or they are fully, let's say, occupied or stable at 8 electrons. We have exceptions. The first exception is the hydrogen. Hydrogen is only stable and pleased and obsessed as 2 electrons. So when hydrogen has only 2 electrons, it is obsessed and stable and everything is good. Now we make a bond. Now this hydrogen will bind to this carbon. I don't give you my own electron. And I am as hydrogen, I can't give you my only electron and I will end with no electron. And I am as a carbon, I can't give you my electron, I can't give you my 4 electrons to each one of you, the 4 hydrogens, and I will end with no electrons in my last orbital. I would not be octet. Okay, let's solve the problem. Me and you are going to share these electrons. I mean, this electron and I will put my electron in the middle. You will put your electron in the middle, and these 2 electrons are for both of us. These 2 electrons for the hydrogen, and the same times these 2 electrons for the carbon. This the hydrogen will say to the carbon, "Hey, please, can you give me 1 electron?" The carbon says, "Okay, I'm sorry, I can't give you 1 electron because I'm non-metal. I don't I'm non-metal, you are non-metal. We are only allowed to share. And I will not be stable if I give you my only electron. And you can't have my only electron and I will be messed of electrons. Let's share this. The solution is to share. These 3 electrons for you and these 2 electrons for me as well. The same for here and the same for there. Now look to the hydrogen. If you count all the outermost electrons in the hydrogen orbital now are 1, 2. So I have 2 electrons in the hydrogen. The hydrogen is stable now because, as we said in the exception here, hydrogen is stable at 2 electrons. Only the hydrogen is the exception? No, we have as well boron and beryllium. We're going to explain it now. And these 2 electrons, and here we have 2 electrons, and here we have 2 electrons. Now count for the carbon 1, 2, 3, 4, 5, 6, 7, and 8. Now the carbon are 8 electrons and already octets. So here I have the molecule, which is CH4, right? Okay, let's have another example, which is the ammonia, which is the most important base, the NH3, the ammonia. Okay, I will draw how the covalent bond form in the ammonia. First, I have nitrogen and hydrogen. I forgot to tell you that you have first to find the central atom. What do we mean, teacher, by central atom? Central atom is the atom with the least number. Right? Central atom is the atom with the least number. Of course, I will put the nitrogen in the center and I will provide the nitrogen with the 3 hydrogens around. Okay, because it is the least number. This is called central atom. And then I will put the single pure electron for the hydrogen here, and I will draw the valence electrons for the nitrogen. Again, teacher, we draw the valence electrons for the element. What do we mean, teacher? The electrons in the last orbital. Again, you only draw, teacher, the electrons in the last orbital, which are the group number. Excellent. Group number 5, as I taught you, 1, 2, 3, 4, and 5. It is easy now, and clearly you can observe that I have 3 unpaired electrons. Nitrogen with the hydrogen, there is no way actually to do losing or gaining of electrons, so the only solution is to share these electrons. Hey, poor electron, I would share mine with yours, so you hydrogen will have 2 electrons and you are stable. And this is the same, and this is the same. Now, please concentrate. Not all of the electrons around the element must be bonded. Again, not all the electrons around the element must be bonded. But at the total, when you count the total number of electrons around the element, they're supposed to be 8 electrons, whether these electrons were bonded in a bond or as a pairs. If I will now count the total number of electrons around the nitrogen, I would say 1, 2, 3, 4, 5, 6, 7, and 8. Now I have 8 electrons in the nitrogen, and this is our covalent bond. Okay? This is easy. Let's take another example, which is water, H2O. This is so important example, and I will give you homework. Please do PiH4 and SiH4. Please do the, let me give you easy thing. Okay, you can do only these. Meanwhile, we take, because there are some exceptions, we didn't mention the exceptions. Now, H2O, where are the central atoms? Where is the central atom? We only have one central atom, which is the oxygen, because it has the least number. I will write the oxygen here, teacher, and I will put the 2 oxygen at the around. Teacher, we noticed that when you draw the atom, the central atom, and the atoms surrounded, you draw it in a specific way, like you draw it like this. In the previous question, if you see, you draw it like this. But if we draw the nitrogen like this, is it correct? Okay, now I will tell you that you have to draw it in a specific way, because the covalent compounds or the molecules, they have specific shapes. They have 3D shapes, and we are going to learn how to know the shape of each one of these molecules. Oh my God, teacher, it is so hard. Do I have to study the shapes for all the molecules here? All the molecules? No, I'm going to give you easy way. Of course, I have solution for everything. I'm going to give you I'm going to give you how to know the shapes for each molecule based on its central atom. So, teacher, after knowing the central atom, you would be able to know what is the shape for this molecule. So you draw it in this way. As for the ammonia, it has trigonal bipyramidal, right? Trigonal bipyramidal, like the pyramids, the Egyptian pyramids. Now, let's go back to the water molecule. The water molecule has a shape of a bent. It is bent a little bit. It's not linear. It is a bent. That's why actually I draw the oxygen and the hydrogen in this way. Oxygen is the group number 6. I'm going to write 6 electrons in the last orbital. 1, 2, 3, 4, 5, and 6. Now, it is easy to know that hydrogen has its only poor electron, No way for losing and sharing of electrons. The hydrogen will share this electron. The hydrogen will share this electron. It is important, teacher, that when you finish sharing of electrons, no unpaired electrons left. No unpaired electrons left. You're supposed to have all the electrons are occupied, are bonded, with other electrons. We have some exception, which is in O2, that we are going to explain it later on. You have exception, okay? But all of the electrons, as you can say, they have to be bonded with other electron, or they have to be pairs, okay? In order to know if your compound is correct, if your molecule is correct or not. If you still have one unpaired electron, this is really incorrect. 1, 2 for the hydrogen, thank you, I am stable. 1, 2 for the hydrogen, thank you, I'm stable. For the oxygen, 1, 2, 3, 4, 5, 6, 7, and 8, I am good, I'm feeling good, right? This is for the oxygen, and this is called covalent. This is covalent bond. By the way, this is as well hydrogen bond, and this is as well, this is a polar compound. We're going to know the properties for the hydrogen bond, and we're going to know that actually this sharing of electrons sometimes is not fair. What do we mean, teacher? The sharing of electrons sometimes, it's supposed to be fair. Put these electrons inside, both of these electrons are shared between me and you. You are not allowed to take these electrons. I'm not allowed to take these electrons for myself. But what happens in real life is sometimes a little bit, let's say, opposite. It's not a big difference. We are going to explain the water molecule, why water molecule is polar, and it is a polar covalent bond because it has a partial positive, partial negative charges. We're going to explain the bond polarity later on through this chapter. Okay, so this is easy right now, and we are going to move to the exceptions. Please move to the exceptions. I will go and write here the exceptions. What do we mean by exceptions? Teacher, we say that hydrogen is happy with 2 electrons. Now, beryllium is happy with 4 electrons, and boron is very happy with 6 electrons. Yes? The chemistry is very interesting. But the problem in each single part of the chemistry, when you start to understand this part, you find a lot of exceptions. Sometimes the exceptions are more than the basic rule. Yes, that's why sometimes the students find it, as they say, hard. It's not hard, but you have to know all the exceptions. Yes, hydrogen is happy and stable at 2 electrons. Beryllium and boron, they are stable at 4 electrons. Boron is stable at 6 electrons. What do we mean, teacher, by this? Let me give you example, and I want you to concentrate in this very, very important question. This is really, really, really important question. I will do an example of Be, beryllium with chlorine, right? Beryllium with chlorine. Beryllium is in group 2. If you open your periodic table as in group number 2, it has 2 electrons in the last orbital. So I will draw 1, 2 electron. Okay, teacher. First, beryllium is in group number 2 and chlorine is in group number 7. Metal with non-metal, they make ionic bond, ionic compound. Listen carefully. Beryllium make covalent compound, not ionic compound. Yes, beryllium share electrons. This is the exception. Please consider this exception. Beryllium share electrons. So beryllium with the chlorine, I will draw with the chlorine. I find it a little bit, you are maybe shocked now. Yes, this is the truth. Beryllium is exception. Number 1, it makes actually covalent bond or covalent compound. Number 2, with the group number 7. Number 2, it is octet only at 4 electrons. Chlorine is in group number 7, 1, 2, 3, 4, 5, and 6. And the other chlorine here, 1, 2, 3, 4, 5, and 6, 7. I'm sorry. Teacher, why did you draw 2 chlorine? Because I have 2 unpaired electrons. And I know previously that beryllium is, it makes covalent bond. As we said in the previous exam, each one of these electrons will bind to the other one by covalent bond, as you can see here. Now the chlorine is 8 electrons. Thank you, I'm pleased. 8 electrons. Thank you, I'm pleased. Look for beryllium. 1, 2, 3, 4. Yes, it is stable and happy at 4 electrons. So the compound is BeCl2. Yes, BeCl2. And if you are going to use our the way that I taught you by having the formula, beryllium is in group number 2, chlorine is in group number 7. So here I have positive 2, minus 1. Even that beryllium doesn't lose 2 electrons and there is no ionic bond between both of them, but you will end with BeCl2, which is the same as here. So this is actually teacher exception. It is important to understand all the exceptions because in your external exams, exceptions come a lot in the exams. Yes, in your external exams. The other one is boron. Boron is in group number 3. Let me, for example, I will draw it here. Boron is in group number 3, and as we said, boron is happy at 6 electrons. See, please, this is my boron, and I will put Cl. Okay, now the boron is in group number 3, 1, 2, and 3. Right? Let me write it in a proper way because it has a specific shape. You will be learned later like this. I will draw this to make a space. Concentrate, please, teacher. It is easy. Just you have to concentrate. I have boron and Cl. Now, I have Cl, BCl3. This is my compound. So, this is my covalent compound. So, I will draw now 3 chlorines. This is the first one facing the only poor electron. This is the other one facing the only poor electron, and this is the third one facing the only poor electron with 1, 2, 3, 4, 5, 6, 7 electrons. I know that now it's easier and you have a full idea how to draw Lewis dot structure for each one. And here I have 1, 2, 3, 4, 5, 6, and 7. I faced each single poor electron with its friend, and then I'm going to share, share, and share. Now, this electron is octet with 8. Thank you. This is octet with 8. I'm happy. This is octet with 8. I'm pleased. This boron is 1, 2, 3, 4, 5, 6. It's not 8. No problem. This is 6 electron. These are the 6 electron. I'm happy. And octet, right? This is the other exception. These are exceptions of the octet rule. And still I have last exception because I am just trying to remember all the exceptions that you may face in your external exams and in your in your practice problem in the book. I still have the xenon, which is Xe. Let me explain it to you. That's why I will do all the exceptions. Okay. Okay, let's move to xenon. I have this compound, XeF4, xenon fluoride. This is really important covalent compound that we have it in our chemical reactions. If I will draw the xenon, and I have 1, 2, 3, 4 fluorines. Now, the fluorines are group number 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I will keep this lone electron facing the lone electron of the xenon. Okay, and then I will make here 2. Here 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so each one of these electrons are going to bind with a single poor electron in the xenon. 1, 2, 3, 4. Okay, but actually I will draw 4 unpaired electrons, but you don't know that xenon has 8 electrons in the last orbital. Don't get shocked, please. Yes. Xenon has 8 electrons in the last orbital. I will draw the first one individually, and then I will say 1, 2, 3, 4, 5, 6, 7, and 8. Again, 1, 2, 3, 4, the individually 1, 5, 6, 7, and 8. Yes. Please believe me. And then this will bind, each poor electron will bind with the other electron. Each one of these fluorines are happy and stable. The xenon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, I am happy and stable with 12 electrons, not only 8. I'm honest. I will give you all the exceptions. Do not get conflict anytime. It's important to know all the exceptions more than the basic rule. You know why? Because in your external exams, even in your books, the exceptions actually, believe me, come a lot. So you have to practice on the exceptions. And that's all about the covalent bond. I am going now actually to move to the slides, to the PDF that we have. We are going to go through again the covalent definition, and we are going to practice more about how to draw Lewis dot structure. I'm going to give you some practice to do it alone, and please concentrate with the next upcoming slides that we are going to explain with now. It's really very big topic. After knowing the structure of the atom that we discussed in the previous chapter, now we are moving to bind these atoms together to make either ionic bond or covalent bond. At the end, we will move to the states of matter when they bond, when they bind to each other. What do they make? Liquid, solid, gas, compounds. So we are going to move, as I told you, to the states of matter, solid, liquid, and gas. So all these topics are related to each other and they are connected. So actually, I advise you to go back to the first video that we explained first about the atomic structure, how to do the electron configuration, the periodic table and the periodic table trends, and move to chapter 2, which is bonding, and then complete with us to states of matter, solid, liquid, and gas. By moving with us in a good sequence, actually, I guarantee you to get the best, let's say the best result. But if you open, for example, a video of bonding, okay, and you didn't actually go back to the atomic structure basic of chemistry, and you don't know what is meant by valence electrons, group number, why elements lose and gain electrons, you will sometimes feel lost. So actually, I provide you to have all this series, complete series, starting from the first video to the last one. Moving now to the slides, going back to the slides, let's see what I prepared for you. All the examples, all the exceptions, all the practice problems in your book, in your practice book, in other resources, and in the past papers of our external exams are all collected in this PDF. Let's start.